I'd like to thank the organizers for inviting me to the conference today. I had a chance to be here this morning, a lot of an eclectic group of speakers, and I think I'm going to continue to add to that in the different perspectives. SAE International may not be that familiar to you. SAE is actually a $100 million enterprise comprised of 3 different companies and organizations. SAE International itself is a membership-based organization of 133,000 engineers worldwide from over 100 different countries. And the core competencies of that organization is technical standards, technical publications, and then the lifelong learning for engineers. We start already at the kindergarten level, go all the way through undergraduate, graduate work, and then continuing on through one's professional career. SAE International works in the automotive industry, works in the aerospace industry, as well as the commercial vehicle industries. Second part of our organization is called the Performance Review Institute. It is a industry-managed quality auditing process for the aerospace industry. If a supplier wants to supply the aerospace industry any part that has a quality reference that uses special processes such as heat treatment, non-destructive testing, chemical etching, it has to go through our audit, and it's a single audit that the entire industry respects and accepts as a single case. The third organization is the Industrial Technologies Consortium, which is essentially an organization where industries can come together and solve technical problems relatively quickly, relatively efficiently. We provide industry-managed services there. We do this again in the aerospace industry for quality as well as environmental issues. So the message I want to leave there before I get into my actual talk is that we're a relatively diverse organization working across the entire mobility industry and really looking at the technical aspects of the industry as well as enabling the professionals to do their job. The talk I'd like to give this morning has 3 components to it. The first, I'd like to talk to you about standards, the role and the benefit of standards. Again, I realize that standards may not be in everyone's lexicon or part of their responsibilities, but it really is an important part of the industrial process. The second part of the talk, I hope to convince you that the SAE Standards process is a preferred process, one that's been adding tremendous value to the automotive and the aerospace industries for nearly a century now. And then lastly, I'll highlight some of the areas, particularly within the auto industry, that we're working right now on standardization, and I'll try to emphasize some of the areas that have the electrical components as well. Looking very specifically at our ground vehicles program standards, the entire standards program has close to 35,000 standards in it. A lot of those are in the aerospace. What I have here is just some statistics around the ground vehicle. We have over 2,000 active standards right now. There's over 600 standards in the development process. Now, SAE International does not develop those standards by themselves. We have thousands of engineers from around the world working together, coming together, sharing data, debating the benefits and the merits of different approaches, and eventually forging a consensus on what the best industry standard should be for a particular aspect. Many of you may recognize SAE 1030 weight oil. That SAE is our organization. SAE actually formed back in the early 1900s simply around the notion of standards. When the Buick, Chevrolet, when they were being formed, the Fords, even the aircraft industry, the simple bolts and the nuts were not compatible. So we put those standards together where they could be shared, the points and the spark plug gaps, etc. We do this through over 470, nearly 500 committees right now. So it's committees of technical experts, people who are dedicated to a specific topic, and they come from the OEs, they come from the supply community, they come from the governments, also as public advocates, coming together to forge the best standard for the need. Now, this is, I don't intend for you to look or read this, but this is actually a simplified diagram of the standards process within the United States. It's a complex partnership between government, between industry, between the private sector. It involves the standardization, the development of standards, as well as the conformity assessment to ensure that one is complying with the standards. SAE focuses particularly on the standards development process. We've highlighted that in red. SAE is actually a certified standards developer for American national standards, but we also play extensively in the global arena through the ISO process, as well as in our own right, our standards are adopted worldwide by many manufacturers. Now, what exactly is a standard? What I'm showing up on the screen is actually the standard definition of a standard. It's not a circular definition, but it really is it's a definition or a description, technical specifications to achieve commonality, consistency, clarity, and removes the ambiguity so that whomever picks up a document understands what the standard is, or if they make a part here, make it there, it follows the same standard, and there's no ambiguity or differences. Now, one of the standards that we all know, regularly see every single day and rely very heavily on is the simple barcode. It looks simple, but it is an extensive document behind there to describe each aspect of the barcode itself so that when the machine reads it, the standard input comes out. You're probably, many of you have probably been engaged in developing the barcodes and working within your organizations to follow parts in your inventory. It's just a simple example of a standard. How do standards come about? SAE focuses on the consensus-based standards, and there's really key parts to this. One, in order to have a standard, we believe in an open environment. Any relevant stakeholder who has an interest in the standard, the outcome of the standard, or the impact of the standard should have a place at the table if they choose. We do not prevent anyone from being at our standards development process if they have a legitimate role there. Sometimes this can be difficult to bring all the different opinions together, but we believe that through that open process, the standard will be of higher quality. We also have a very transparent process. All of our standards are developed and the information is cataloged and it's available to the public. So there is no secrecy that goes involved. Again, that creates some challenges when you come around intellectual property. But again, this, we believe, is a pre-competitive role rather than a competitive part of the process. So if there is a question in the process, you can come back and see how that standard was developed. There's also a due process. It's a very clearly defined process that we go through. Steps are not skipped. We go through this. There's a series of votes and approaches to ensure that we have attained consensus. And there's also an appeals process as well, so that when it's all said and done, if something isn't quite right in someone's mind, they can actually appeal the process as well. Now, in that description, and I was just listening to the previous speaker talking about speed to market, you hear all the words that I'm saying, you might be concerned that a standard can be a slow process. It can be, and the more complex it is, sometimes it does take a while. But the SAE process is also one of the quickest in the marketplace. We have been known to get standards out in close to 45 days if there's a clear need, a clear articulation of the problem that's being solved, and a clear will to get to the end product. On screen here is the 6 requirements that the World Trade Organization requires for standardization. The triangular diagram I showed before is the process that we use. The process that we use actually fulfills all the obligations of the World Trade Organization. The WTO ensures that technical barriers to trade don't come up. The purpose of this slide here is that the standards that we develop through our process are immediately applicable in the international domain because of the process that we use. Why are standards important? Standards are around us everywhere. The standards can define the shape, the sizes, the dimensions of activities. It can define performance criteria for products or for people. In the upper left, you just see a series of things that we use every single day. And we plug our computers into a network. The connectors are defined, size, shape, pin configuration. We don't think anything of it, but we know that whatever jack we go to, hopefully the network will be supporting behind it. Things simple as batteries, the D-size battery, the C-size battery, the AA size battery. All those dimensions are defined, the voltages are defined, so that we can buy any battery and put it into any device, and you can design the device accordingly. In the automobile, a whole series of different standards go into it. The one I showed there on the bottom is sort of the emerging field, is the electric vehicle and the charge coupler. what it's going to take to plug in. I think we've all gone through mobile phone changes and having to change connectors and go back to the store and buy another charger for our car because it doesn't connect with our old phone. When they're only 50 cents, $1, $2, it's not a big deal. But the charge coupler on vehicles can run upwards towards $2,000. So if you really do want to get electric vehicles adopted into the marketplace, you can't have the consumers switching $2,000 in your connectors if you go from one manufacturer to another. Now, standards in the end, what they can do is they can help unify global markets. They can reduce your inventory and part numbers, reduce costs. You see the other list. They really can facilitate cost efficiencies, time efficiencies, and in performance as well. Now, a couple of case studies. I mean, standards have been around for a long time. The first one I list here actually goes all the way back to biblical times. Basically, don't cheat your neighbor. There was defined of what a standard was going to be for a certain measurement. And now you see it goes forward in time. 1904 was one of the times that the United States really faced standards for the first time. The Baltimore fire of 1904 was raging out of control. The Baltimore Fire Department couldn't maintain it, so the local cities of Philadelphia and Washington, D.C. started to send up equipment. Great idea, but when they got there, their hoses didn't connect to the fire hydrants. So all the equipment that was sent up was essentially worthless. That is actually the formation of what was the National Bureau of Standards, and now eventually is the National Institute of Standards and Technology. This is one of the earlier forms of standardization in the United States. Another example, during the Civil War time, there were 33 different gauges for the railroad. You get to a certain state, get into a certain city, and you can't use your rail car because the gauges of the tracks are different. Congress eventually looked to standardize that. 25 years later, not only did the United States, but the United States, Canada, and England adopted our standard as well. If I'm not mistaken, the only rail that's different right now is the former Soviet Union, and I think that was done for clear reasons to control transport. Standards are important not just on a national basis, but on a global basis as well. What you see here is the charge coupler I mentioned earlier. J1772 is a standard that we created for it. The standard isn't just concerned about the physical dimensions of the coupler, but it also deals with the performance of the charge coupler. In the United States, we use 120 volts to charge in our household. Most homes also have 220 volts, particularly for their ovens and their stoves and their laundry machines. So our coupler considers both the 120 volt as well as the 220 volt charging that could take place in the home. It also is going the next step of looking at DC charging, where you can do rapid charging at 600 volts. So the standard itself is taken into consideration the physical dimensions, the performance, and the requirements. The challenge for the industry is the regional differences around the world. We use 120 volt single phase. Europe often uses 200, 220 volt three phase. So how do the connectors and the couplers start to consider that? SAE has been in the lead in developing these, and we've been trying to work worldwide to harmonize it so that the industry can settle down onto a single standard. By doing so, they can eliminate a lot of cost. The sheet metal bending that needs to go into a vehicle, you don't want to have it different sizes for different couplers. One of the challenges here is that there is some efforts to bias domestic manufacturers in the process. So if you have a unique charge coupler and you only provide that standard to your manufacturers, you can give your local or your domestic production a little bit of an advantage over the global competitors. We're seeing some of that on a regional basis, but the SAE is trying to take the lead to work through all of that and get that common standard. What's the cost of standardization? Some people get concerned about the time it takes, the technical expertise, the engineers to travel the consensus process, and it isn't cheap. But more importantly, the cost of not standardizing things can be tremendous. A couple of studies have been done. Automotive News back in 2001 actually measured that the lack of standardization was costing the automotive industry alone $20 billion. The U.S. Commerce Department has looked at this. And Germany has looked at this as well, and they have found a direct correlation to cost savings, productivity, economic benefit to creating standards, not just on a national basis, but on a global basis. Now, standardization in the United States has its basis in the industry itself, trying to find efficiency. But the federal government also has gotten involved and has promoted the use of standards, particularly in the regulatory framework. Standards are not exclusively used for the regulatory environment. The bulk of standards are used just in the manufacturing and the technology process. But in those areas of the environment, safety, the federal government has begun using those standards in its process as well. And in 1995, there was the National Technology Transfer and Advancement Act actually encouraged and explicitly stated that the government should try to use private sector standards when they exist. There's also an executive order from the Office of the President that also promotes that use. A couple examples from SAE. I think we'd all like to think that our children need to be protected. And so SAE worked very closely with the technical experts in the industry, experts in the public safety advocacy community, as well as the technical experts within the government, to form standards around child safety restraint and the way the child safety seats are actually secured in the vehicle itself. All of that was done under the aegis of SAE International and working with the committee process and ensuring that open, that transparent, that due process and the consensus used. And now we have a single standard that is actually used worldwide. Another example is the lighting standards. The standard that we worked on is referenced in federal regulations directly. The standard itself is not incorporated into the standard, but it's referenced. This has also found itself into the state regulations. So my point here is it's the federal, but also states begin to adopt standards. And if every state started to adopt a different standard, imagine the complexity of actually delivering product in that environment. So we try to work at the state level, the federal level to adopt a uniform standard, and actually going on further into the global, and I'll touch base on that a little bit. In the upper left, you see a variety of federal agencies, NHTSA, the National Highway Transportation Safety Agency, EPA, Environment, it's mining, OSHA. All of these different agencies have adopted, incorporated our standards by reference into their regulations. On the lower right, you'll see that the standards have also been adopted globally by a variety of countries and different international global regulation and safety bodies. Now, what's the advantage of using standards in the regulatory process? There's many. One is it actually leverages the technical expertise from the private sector. I'm not here to say whether big government or small government is the right answer, but I think that you can accept that relying on the technical expertise that the industry is investing so heavily in developing in partnership with the regulators is a positive thing. So as industry expands and contracts, as government expands and contracts, having that partnership is essential to ensure that the regulations are based on sound science, sound technical activities. We also believe it helps get speedier regulations. If you relied solely on the government bodies to do that, it's a tremendous workload on them alone. When you get into the public environment and the standards environment, you can get a lot of technical experts coming together relatively quickly to reach that standard, that desired consensus point, and move forward. It also improves the responsiveness of the regulations. Whether it be regulations or other activities, when two people are doing things in different rooms and not talking to one another, they can come out with very different solutions. Both can be equally good, but sometimes you have to harmonize them. So by using the standards process up front and incorporating the regulators, you can get common answers much more quickly. And ultimately, by having that open process that I talk about, having the stakeholders and the advocates for a particular aspect involved in the standards process, it gets to a quicker solution than creating a standard and then trying to adopt it later to the public advocates by including them in the process up front. It may take a little bit longer in the upfront, but you have a much quicker implementation phase. Let me turn to the global standards here. Now, who all create standards? Right here you see the national bodies. These are the organizations that are probably the most prominent in the automotive space, that are France, Germany, the UK, Australia, and Japan. China increasingly so, and India will be coming up as well. SAE works through the American National Standards Institute to partner with all these organizations in the ISO process, which I'll touch on in a minute. But we also work directly with some of these organizations to create our standards as well. SAE is a strong advocate for a multi-path approach. And by multi-path, we believe that there are multiple ways to get to good quality standards. In some cases, they're an industry-based standard or industry groups, closed groups. AUTOSAR, GENIVI are two examples where AUTOSAR is where the OEs, the suppliers, software developers, and others come together and they've established their own standards, their own approach, and you can get very quickly to solutions that meet industry needs. GENIVI is dealing with the infotainment. It's a not-for-profit alliance that has set up standards to help move the infotainment into a common platform. The challenge with industry standards, I got one slide out of order here, so I apologize. The India consortia standards, they can be quick to formation, which is very good. It helps the industry. And they can be very specific to the needs of the industry. One of the downsides of industry consortia standards is that they're not open and public and transparent. And if it is ever going to have a safety impact, a quality impact, environmental impact, where it starts to get in the domain of the regulators, they're disinclined to use industry-based standards. So that's where we can be that interface with the industry itself. Not that those standards are inferior, they could use due process, but because they're an industry base rather than an open base, the regulators aren't quick to adopt them. The ISO and IEC, those are common acronyms that if you're in the standardization world, you know. ISO is an IEC, they're located in Geneva, and increasingly national governments are adopting ISO as the preferred methodology for standardization, and I'll explain why that is. Essentially, it's one country, one vote. That has its benefits in a standardization process, but one of the downsides of this process, it's political, and when I say political, it's a small p political, one country, one vote. So when the United States goes to the table and advocates a position, it has the same weighting as the Democratic Republic of Congo, who probably does not produce any parts for the automobile. But you can get to differences of opinion without any impact on how much gravitas or how much bearing you actually have on the industry. But on the other side, it does give every country an opportunity to participate equally in the standardization process. Let me give an example specifically of the cars and the automobiles. And this is not an anti-European speech, but it demonstrates a challenge that we have in the automotive space, at least dealing with Europeans. What you see here is Europe, and then China, India, Japan, the United States. Those are the major places where automobiles are being manufactured and designed. And what you see in that first pie chart is the relative balance. Green here is the European Union balance, and the blue is the balance of China, the United States, and Japan. You see that about a third of the production is European. Vehicle sales are close to a quarter. But when it comes to votes and the regulations, because the European Union, each country has its own vote, it can have 27 votes to the 4, which is a very disproportionate amount of voting capacity or voting power with respect to standardization. And then the number of ISO secretariats that they maintain, that's a volunteering choice to do. They believe in the ISO process, so they use it. But we feel that in the end, the ISO process is probably not beneficial right now to the automotive industry, and the automotive industry has used SAE as well as ISO, but so far they've been biasing towards the SAE process. As an example of another industry, the aerospace industry had to have global standards a long time ago, before ISO existed, and they have not used the ISO process at all. They can get standards out much more quickly, and it's industry relevant rather than a political process. ISO serves its role, but we don't believe its effectiveness in the automotive space is as good as alternatives, such as the industry consortium or SAE's model. SAE standards do end up in the global regulatory process quite frequently. I had a slide earlier that showed that. How does it come about? On the bottom left, or in the bottom middle, you see a relatively excited engineer about the need for a standard. This is they can come towards the SAE process and work through with their peers from a variety of different companies, with their counterparts in government, to develop the standards. And those standards find their ways back into the vehicle design, manufacturing, and production process. In some cases, our standards actually do move on. ISO is looking at a similar process, and they will look at our standards through a TAG, a technical advisor group. They can be incorporated into the ISO process or the IEC process, and then that finds their way into the vehicles. From our standards committees, they can go directly into the regulatory process, and increasingly WP29, the Working Party 29, is dealing with the global harmonization of regulations, and so our standards are finding their way into the global regulatory process as well. Oftentimes that comes in through the ISO process, but not exclusively. So that's a little bit of background on what standards are, how they come about, and the processes that we believe are beneficial to the industry. Well, I close up with just a few slides on the areas that we're working on technical standards in the electric vehicle space. We like to describe it as sort of the new era of mobility, and why now? There's a lot of excitement around the electric vehicle. I think the market adoption may take a little while, but there's a lot of driving forces behind it. World energy concerns. I just came home after being out of the country for 2 weeks, and I was pleased to find out that gas prices dropped another 25 cents. But longer term, it's clear what's going to be happening. There's going to be increasing cost pressures on the individual, and there is a limited supply ultimately, whether it's 2050, 2090, 2190. You make your call on when we'll run out of the energy resources of petroleum fuel, but it will be there. The environmental impacts continue to be of concern at a government level, at a private level, and then ultimately the sustainability concerns. So the electric vehicle has a lot of drivers behind it. It'll be uneven for a while, but it's our mind, the trend is very clear. As you look at that electrification of the vehicle itself, I mean, in the 1970s, the only electrical device you really had on there was the windshield wiper motor and the radio. Now you look at your car, significant amount of its value is in electrical components, and the trends only can continue. Now as we go to electric vehicles, we have large storage devices that need to be on board. Tremendous amounts of current are flowing through vehicles. It's no longer the 24 volt. You've got high voltages that are flowing through there. The power electronics and the power motors that are going to take place. The V2V, vehicle to vehicle, vehicle to infrastructure, digital short-range communications, all of these things are in play right now in the industry, and they're ripe for standardization. Standardization can squash out innovation, so you can't standardize too quickly, but once the technology is clear or a preferred model, the sooner you can get to standardization, the quicker you can get towards performance and cost reductions. We're also seeing much more moving from a passive safety to an active safety. Used to be a seat belt, then it became anti-lock brakes, electronic stabilization control. Now it's also advanced cruise control, lane detection or lane diversion technologies, the information systems in the car, and the function. All of these are starting to come to play. SAE is working very actively through its committee process to identify those areas that are ripe for standardization. One of those is connecting to the grid. The interesting challenge here is you've got two industries that really never had to worry about each other before, the electrical power creation and distribution industry as well as the car industry. Just think of all the electricity that has to be consumed and distributed if we go to a fleet of vehicles that's even 1% based on electric power, let alone 10% or 50%. The power companies are beginning to look at this, and that's one reason why we wanted to have that interface, the charge coupler, standardized, because it wasn't just the power, but it was also the communications going back and forth between the vehicle and the power grid. Increasingly, the states and jurisdictions are charging different rates for electricity at different times, so your vehicle has to be intelligent enough to know when to charge, when to not charge, or provide power back into the grid if it's not going to be actively used over a short period of time. So our standards are working at that. NIST has actually identified SAE International as the leading standards developing organization to deal with the interoperability of standards dealing with electric vehicles. So a lot of our committees, 29 active committees in this area, over 700 engineers are involved in developing these standards. Connecting to the new energy sources, the battery and the power packs, how to go about standardizing down at the cell level and moving all the way up through different aspects of the battery itself. This has been a rapidly developing area. A lot of people are coming in and partnering with us. Again, more than 400 representatives are involved, 140 companies. New companies, new startups, long-time companies are involved in this. This has been an area that's been keeping us very busy and developing new competencies. Last slide that I have here is just, it's not intended to be futuristic. It's not futuristic at all. It's actually happening today. It's all the different connections that we have to make. It's the vehicle to vehicle. Our vehicles will increasingly be talking to one another, anticipating where the cars are, feeding information back and forth, ultimately leading towards guidance on faster routes, environmentally friendly routes. Vehicle to device, our mobile phones no longer stay outside the vehicle. They're becoming a critical part of the vehicle itself. It won't stop there. It'll continue. And then the vehicle to infrastructure. It started with the fire engines communicating with the traffic lights ahead, but now our vehicles will begin to do that as well. Again, optimizing traffic flow patterns as well as the traffic avoidance situations. The upper one, I think is quite interesting. Will the communications ultimately be between the human itself and the vehicle? The brave new world is out there, but it could happen sooner than we anticipate. So with that, I'd like to finish up by why relevant to you. Hopefully, if you haven't been involved in the standards world yet, you've seen some connections here for yourself. One of the key aspects of good quality standards is having the engineers who are actively involved in design and manufacturing a product to be involved in that standards process, to bring the knowledge, the expertise that you or your company have. Key thing is if your organization, your company isn't involved, standards happen to you rather than being an active part of the standardization process. You can be relatively proactive in the standards process to identify those areas that need it. In the end, you can adapt to the standards much more quickly if you've been a part of creating them. Your cost reductions increase the quality of your products, and most importantly, your engineers, it'll make their lives easier, and in fact probably more enjoyable because they get out and get to work with their colleagues a whole lot more. So we believe it can be a bottom line impact for you and a tremendous benefit for the industry. Jack Pocheva, my colleague, is not able to be here today because he's actually in Geneva working on ISO and IEC activities, but I have two more of my colleagues here with me today actively involved in the standards process. But we'll leave this presentation, and Jack is always available to talk in more detail.